What are your eyes used for? To see stuff. More technically, to detect stuff. To detect a lion about to eat you. To detect an iffy-looking mushroom that might kill you. And plenty of other things. A detector is something that measures light after it has been brought into focus. In our lesson's case, brought into focus by a telescope. While the human eye is a qualitative detector, there are plenty of other kinds of ways light can be measured. These ways, which are more sensitive and objective than our eyes, will be outlined for you here. One way to record the things astronomers see in a telescope is the same way you'd record something you see with your eyes for posterity. You use photography. A telescope can be used like a camera. Its objective, the primary lens or mirror, is like a camera's lens. Thus, the eyepiece of a telescope can be removed, and a photographic plate or film can be put in the focal plane of the telescope, as it would be placed in the focal plane of the camera's lens. Now, while you might snap a picture really quickly here and there with your camera while having fun with friends, astronomers usually use very long exposures instead. This is because long exposure times are necessary for them to get good images of celestial objects that are way too faint for your eyes to even see. Even so, photography is not a very sensitive or efficient way to record images when compared to the use of CCDs, or charge-coupled devices. You've probably heard of these guys being used in higher-end video cameras. A CCD is a device that can be made up of a million or more photosensitive detectors confined to a very small area, the size of a postage stamp. Such an array of detectors is laid out in a mini chessboard-like pattern, where each piece of the pattern in a CCD is known as a pixel. The sensitive nature of a CCD gives astronomers the ability to produce much better images of faint celestial objects than photography ever could. Photography should not be confused with photometry. Photometry uses instruments called photometers, and it refers to the measurement of the brightness of celestial objects, such as planets, galaxies, stars, nebulae, and so on. While ancient astronomers used their eyes to subjectively measure the apparent brightness of these objects, a photometer does this far more precisely by way of light hitting the photometer and producing a measurable electric current as a result. Another powerful way light can be used thanks to a telescope to measure and analyze celestial objects is known as spectroscopy. Spectroscopy is the study of patterns of spectral lines emitted by chemical substances. In spectroscopy, light entering the telescope is later dispersed according to wavelength to create a spectrum, an arrangement of electromagnetic radiation, which includes visible light, placed in order of wavelength. Thanks to spectroscopy, spectral lines called emission and absorption lines of chemical elements and molecules can be measured. Such lines are unique in their patterns to a specific chemical element or molecule. Essentially, they are like a unique pattern of lines in the barcode for a specific product in the store. In spectroscopy, they are a unique pattern of lines for a chemical substance in a faraway celestial body, like a galaxy or quasar. Spectroscopy uses an instrument called a spectrograph, a device used to measure the spectra of celestial objects. Such a spectrograph has a slit that's in the focal plane of the telescope. This is important because the slit restricts the light entering the spectrograph to a very small area of the sky. If you didn't have the slit, you'd have way too much interference coming from other spectra you could care less about in the night sky. Just imagine standing in a room with several lamps in front of you that are emitting light. If you wanted to really focus in on one, you could cover your eyes with your hands and just barely open up a space between two fingers to focus on the light of only one lamp. That's what the slit is there for. After passing through the slit, the light is then dispersed by something like a prism or grating and refocused on a CCD to produce a spectrum that can be recorded and analyzed. The CCDs, or charge-coupled devices, used in a spectrograph contain many little detectors. A detector is something that measures light after it has been brought into a focus, and a spectrograph is a device used to measure the spectra of celestial objects. The spectrum measured by a spectrograph is an arrangement of electromagnetic radiation, which includes visible light, placed in order of wavelength. This spectrum may have lines, spectral lines in it, which give away the object's chemical composition. The study of patterns of spectral lines emitted by chemical substances is known as spectroscopy. And while spectroscopy is one way to detect and measure light, there are other things astronomers can do. They can rely on photometry. Photometry, which uses instruments called photometers, is the measurement of the brightness of celestial objects, such as stars. And they can use photography, with long exposure times, to detect objects so faint that our eyes cannot see them.